Greetings, geometry students. Here is an overview of Chapter 7, which will include your 7-1 that you begin today. As we begin, let us remember our good friend Euclid, who reminds us, once again, there is no royal road to geometry. As we begin this Chapter 7 overview, in 7-1 it talks about concave and convex polygons. So I just want to review that with you. A convex polygon is one in which if I put 2 points inside the polygon and connect it with the line segment would always be inside the polygon. All right. A concave polygon is one in which I could make a line segment between 2 points that are inside the polygon where the line segment goes outside the polygon, and this does here. Kind of looks caved in. That's one way you can remember. Concave, it looks like someone caved in one side of it. Convex. Alright, so that's just a little bit to get you understanding what they mean by that. We've talked about that a little bit, but not that much. So, okay. So in 7-1, we have some vocabulary. These are the main concepts in 7-1. A diagonal of a polygon is a line segment that connects any two non-consecutive vertices. That means that the vertices are not next to each other. A and B are consecutive vertices. B and C are consecutive vertices. D and C are consecutive vertices. So a non-consecutive vertex would be the opposite ones here. So there's a diagonal, there's another diagonal. A rectangle is a quadrilateral, each of whose angles is a right angle. And I think you know that. So there's your rectangle with the right angles. Theorem 24 is going to be a new theorem here. And this is one thing you're going to find in Chapter 7, is that there's a lot of stuff that we're going to prove that are things that you already knew from experience. The sum of the angles of a quadrilateral is 360 degrees. All of you knew that. All of you knew that the rectangle has 4 right angles. And the corollary here to Theorem 24 is that a quadrilateral is equiangular if and only if it is a rectangle. As you know, there are 4 90-degree angles in this rectangle. Remember that a square is a rectangle, and that's another thing that we'll spend some more time with in this chapter. What happens in 7-2? In 7-2, we start talking about rotational symmetry. So that's something that you can look forward to. 2 points are symmetric with respect to a point if and only if it is the midpoint of the line segment joining them. That has to do with rotational symmetry. Now this number 2 here is the most important concept in Chapter 7. It's about parallelograms, and we find that so many of our quadrilaterals are parallelograms. Rectangles are parallelograms. They meet the definition. Opposite sides parallel. Squares are parallelograms. Rhombuses are parallelograms. What we normally think of as a parallelogram, of course, is a parallelogram, right? And so there are 5 sufficient conditions for a quadrilateral to be a parallelogram. That's found on page 271, and you must know these backwards and forwards. Its opposite sides are parallel. Quadrilateral is a parallelogram if its opposite sides are parallel. It is a parallelogram if its opposite sides are equal, or if its opposite angles are equal, or if 2 opposite sides are equal and parallel, or if its diagonals bisect each other. So when we try to prove things that being parallelograms in this chapter, we're going to try and show that we have met one of these 5 sufficient conditions, and that's when we can say it's a parallelogram. All right, but you don't have to worry about that today. But I think that if you're going on a journey, a Chapter 7 journey here, it's good to know what the trip is going to be like. And so that's what we're doing right here today. All right, 7-4. There is a quadrilateral hierarchy chart, and this is it. Okay, so as you can see, a square is down here at the base because it meets the conditions of a rhombus. It meets the definition of a rhombus of 4 equal sides. It also meets the definition of a rectangle, that it has 4 right angles. Rectangles are parallelograms because parallelogram, the definition involves the fact that the opposite sides are parallel. And that is true of rectangle, rhombus, and square. Trapezoid is its own animal over here. It doesn't have the opposite sides parallel. You're probably used to trapezoids that look kind of like this. It's got one pair of opposite sides that we call bases. All right, so there are some theorems that come out of this that you'll learn in 7-4. All rectangles are parallelograms. All rhombuses are parallelograms. The diagonals of a rectangle are equal, and the diagonals of a rhombus are perpendicular. You don't have to worry about this today, but just want to make sure that you're understanding where this Chapter 7 journey is going to take you. All right, and the final two lessons of Chapter 7. A trapezoid is a quadrilateral that has exactly one pair of parallel sides. 7-5 is about trapezoids. How is an isosceles trapezoid different from a trapezoid that is not isosceles? Its legs are equal in length. So that one I drew for you on the previous slide is generally a classic isosceles trapezoid. These are called the legs here and here, equal in length. How is that different from another trapezoid? Well, here's another trapezoid that is not isosceles. Okay, meets the definition though. It's one pair of opposite sides that are parallel. All right, so theorem 35, the base angles of an isosceles trapezoid are equal. So you can say those angles are equal and these angles are equal. Theorem 36, the diagonals of an isosceles trapezoid are equal. All right, so if we drew in the diagonals there, we would see that as well. Those are the diagonals, and they are equal to each other. And a midsegment of a triangle is a line segment. This is 7-6 here. That connects the midpoints of two sides. So what is a midsegment? If these are the midpoints of that triangle, then this is the midsegment here. The segment that connects the midpoints of two of the sides of the triangle. All right, so then theorem 37, you're going to use this over and over and over again. We should get to this before Christmas. A midsegment of a triangle is parallel to the third side and half as long. So if we have this situation here, we're saying that DE is parallel to AC and half of its length. So if AC is 8, DE is 4. And you'll learn that when we get to 7-6. That's a quick tour through the chapter. Let's go back and remind ourselves about 7-1. That's your task for the day. A diagonal of a polygon is a line segment that connects any two non-consecutive vertices. A rectangle is a quadrilateral, each of whose angles is a right angle. Theorem 24 is new today. The sum of the angles of a quadrilateral is 360. And a quadrilateral is equiangular if and only if it is a rectangle. So your homework for today is right here. 7-1, pages 260 to 263, problems 1 through 15, 28 through 55. All right, well, I've missed you the last couple days here, and but I'll be back, and I will see you when I return. So I wish you a very geometric day. Bye now.